Hello guys, welcome to my channel Analytics with Ashish. So in this video series, I'm going to cover different aspects of machine learning, starting from very basic data exploration to EDA, data pre-processing, different machine learning modeling, and if time permits, and also the deployment aspects. Throughout this video series, I will be referring to Microsoft Git repository where they have put some reference notebook for machine learning algorithm. So I'm going to use those notebook and then try to explain using those notebook in a very simplified way so everyone can understand who are following this video. The assumption is that you have some basic knowledge of Python. Even if you have a little bit knowledge of Python, that should be enough, because in this video I'm going to start from very basic and then we will slowly move towards the advanced portion. And if you follow this video, my objective will be so that you have enough understanding so that you can take any project in industry, and also you can work on your own projects, or you should be good enough to take any interview. Okay, so in Python we have different data structures like list, dictionary, set, tuple. I hope you know that. So that much of basic understanding I'm expecting from you guys. So let's just take this simple Python list data structure. So the way to define this list is like anything with between this square bracket, and then we put all elements separated by comma, so that becomes our list. So even if you want to see the type, you can see the type of this particular variable is list. You can use some basic inbuilt function of Python like length, and then you can use this, and then you can see that in that list we have 22 different elements. Okay, similar to Python list, we have something called array. Or if you're coming from computer science background or from any other background, then you may understand that then you may already know that we have something called array, which looks similar to this. But the difference between array and list is that list can have different type of elements into one, but in array we need to have the same kind of. So whenever we are having some mathematical or numeric elements, then it is good that we can convert that list into numeric array. To use that numeric array, we have a library called NumPy. So let's import that library. Import NumPy as NP. So NP is the alias name, so that we don't need to type NumPy as every time. We can just use NP and dot. We can use any method. So like we have a method called array, np dot array, and then we pass this variable list. So with this, what we are trying to do, we are telling that okay, take this list and convert this list into an array, and that method is basically coming from NumPy array. So this is what happened here. So let's give this a name. So let me give this a name as grades, because this data is coming from student grade. So I created an array here and then I put this into a grade. So let's see that. So if I see grade here, so that's basically what we have. Okay, now it looks similar to the list, but there are difference between list and array. uh, Array can be very good for doing any mathematical computation. So in that case it becomes very useful. Also it provides a lot of mathematical functions which we can use, for example, like like you can use mean, median, and those different kind of things you can use, which is good with any numeric elements. Okay, so now the thing, like if you want the basic difference between list and array is like, for example, like if you want to have data and then you want to multiply with 2, then what do you see? Okay, yeah, let me print this so that it can get, so we can see this into one line. Okay, so what it is happening is like it is taking all the list of element and then it is just like repeating another time. This is not what we want, right? If we are dealing with numeric values, then what we were expecting is that the two should get multiplied to each and every element. Now let's try to do the same thing with the NumPy array. The data set, the variable name is grade, and let's see what happened here. And let's see when we multiply with 2, so each and every element of that array is getting multiplied by 2. So this is just an example that how NumPy array can be effective as compared to list whenever we are dealing with the numeric. It doesn't mean that list is any less than NumPy array, but it's just that in this case, in some cases we need NumPy array, in some cases we need list. Okay. So let's explore more into this side. So with this, we can see the shape, that's the attribute, and then that gives the more information about this particular variable. So we can see that we have 22 elements into our array. Now if we want, we can use this to use some mathematical equations, functions like mean. So that basically gives us the mean value of all these elements. Okay, if you want, we can also do the max, and then that gives the maximum value of all the elements. Okay, now let's slowly start moving towards the case study. So we are dealing with student data. So right now we have the grades, and now let's put the hours. So we have a list of study hours, and then we have study hours for all the 22 students. Okay, so that's a list. Now what we want to do, we want to convert this also into a NumPy array so that it can be easy for us. So NumPy array. And now I'm creating a one array where I'm passing both the values, so like we have grades, and then we also have study hours. Okay. Yeah, I'm getting the error because I need to pass this into this here. Now if I do, yes, I'm getting a 2D array. How do I know that it's 2D array? Quick, like that, okay, we are passing two elements, so that's why one element is still here and the second element is starting from here to here. But also a quick way to understand that if it is 2D array, when we see two square bracket, that's a quick way that, yeah, we know that this is a 2D array. If it's 3, then we see that it's 3D array. So let's put this into a variable. So let's say we have a student data, and now we can see that the student data dot shape, and it gives us, it's a 2D array of 22 element each. So that's what we get to see. Okay, now because it has two elements, so if you want to access each element, then we can do that, right? And how do we do that? The same way like we used to do, like we have index 0, that will give you the first element, and if you want to give this second element, then the index 1. And if you want to check, so this is your first and then you can use mean, and then it is giving you the mean value of your first element. So that's how it works. Okay, now I'm going to copy paste okay, before I do that, like NumPy array, this is very important libraries. Another important library is pandas. I'm sure you may have heard about pandas. If you know about Python, then you may know about the pandas as well. So let's import that library, import pandas as PD. Okay, so with pandas, it has a very important data structure named data frame, which is very important, which is very useful. It is basically a replacement of structured data. So let me copy this code here. So what it is doing actually, pd.dataframe. So from this pandas library, we are using this method called data frame, and here like we are converting this dictionary into a pandas data frame. So this is basically a dictionary where we have key and these values. Okay, so study hours, as we can see, this is our study hours. Then grade, we can see that we also have grade from our student data. It has, we can see from here, this is our grade, and this is our, sorry, this is our student hours, and this is our grade. So that is what we are passing here. So we are creating a data frame here, df students. If you want to see the type, we can see it's a data frame. Okay, now with this data frame, we get a lot of methods as well. Like with every data structure, there is a lot of inbuilt methods as well which we can use. So let's explore that. So df students, if you want to see the top 5 rows, then we can use head. By default, it gives you 5 rows. If you want more rows, you can give 10, but by default it gives you top 5 rows. And then we can quickly see that we have 3 columns here, and then we have these observations. Fine. The other thing is, like, if you want to do that, and you can also use some describe methods, which will give you quick statistics of all the numeric columns, only for numeric columns. and then here we can see with count, min, standard deviation, minimum, maximum. You can also try for this, if you do include equal to all, then it will also include the categorical one, but yeah, mostly like, okay. Now if you want to slice your data, so this is our data set, and now what I want is, you can also access the column by just using the dot, so name, and now I want all the observation of Rosie. So I can pass this will give me true and false. Wherever it finds the observation, it will become true, otherwise it will become false. So let me pass this into a data frame. Okay, and now I will have only those observation where the name of the student is Rosie, and we have only one such row, so that's why we are getting that observation. Okay, so this is one way that we can create our data frame. The other way is like, mostly in industry we get the CSV file, or we are accessing from the data frame. So in pandas we have different methods. So if you want to access, or if you want to load a data from a CSV file, there is a function called read underscore CSV, and then you can pass your data file, so for example, like in my case, the data is in my working directory. So just pass the script.csv, and then we can, okay, let's see. So that's our data set. The same data set, I have put that into a CSV file. So let's give this as a name. Okay, now quickly let's see how this data look like. Looks good. We can use describe and all. What I'm interested right now is looking into if I have any missing values here. So for that you can do is NA, and that will give you if you have any missing values or not. So you can see basically it is looking for each and every cell and then finding if it has any missing values, and if it finds, then it gives you true. But we want to count those, because if the data set is large, then we cannot just see like this. So if you want to quickly see, then you can use the function called sum, and it will count all the trues. And then we can see that in this column and this column we have few missing values. Okay, so is NA is a function which we can use, and there is also a function called is null, which also gives the same thing. Okay, now uh, now if you want to replace those missing values, how to deal with these missing values? Either we can drop those missing values, either, or we can replace these missing values. For example, like let's take both examples. So df students, and then we know that we have missing values in this column, study hours. And then what we are going to do is, like, we say fill NA. So it will find all the NA, and then we are filling those NA with something. And what is that thing which we can decide? So generally in this case, what we do is we replace it with the missing mean values. We can use mean. And as you can see right now, let's see first. So we have missing values in study hours here, the last one, and now we are replacing that missing values with mean. So we can even see that, okay, now it has replaced this with 1041, which is this. So that's one way. Or if for some reason if you want to drop those missing values, then also you can do that. For example, like the second data frame or second column which we had, it also has missing values, right? So in that case, what we can do is df students dot drop. So it is saying that, okay, find those NAs and drop those NAs, and we are saying that x is equal to 0. That means we don't want to drop a column, we want to drop the particular row. So let's do this and then assign to a data frame. Now we can see that we don't have any missing values because we drop. So either we were having more number of rows, now we have less number of rows because we dropped that one observation, because we were having missing values. Now when we have this data frame, we can use several functions, like mean. So for example, like let's do this one. So here what I'm doing, actually, like df students, in that particular column study hours, take the mean value and then assign this to mean study. And then similarly we are doing this for the grade. So now we have two mean study and mean grade. Now what you can do is sometimes, like for example, like if you want to check in the data frame if the value of study hours is greater than the mean study, that you can do. So this put study hours, and then we say that okay, it should be greater than mean study, or like we are interested to see those records where the study hours is greater than mean study. Okay, this will give you all the true and false, and if you want to see those rows, then you can put this into a data frame, and then we have those observation where they are greater than this. Okay, so this is how you slice your data. Same way you can do for the grade as well. Okay, and now even if you want for suppose like this is your slice of data, and now you want to perform certain operation in this data frame because this is a new data frame, so you can even do grade. So in this data frame, look into the column called grade, and then give me the mean value of that. So it will give you the mean value of grade into this data frame, not in this data frame. This is different. Okay, so like this we have already seen, this is different. This is from entire data frame, and this is only coming from this one where the students study hours is greater than the mean one. Okay, now suppose we want to create a new column, and where we say that if the study hours is greater than the mean study, or no, or let's take a column, this one. So here we are creating like pandas data frame. We have a function called pd.series where we are taking where the grade is greater than 60, then we call it as a pass. Okay, so we do that, and then this will basically give us all the true and false. Where it fulfills the condition, it gives you true, otherwise it gives you passes. So it is just checking that. And now I want to create a new column into DF student. So right now I have only 3 columns, I guess. Yeah, 3 columns. And now I want to add a new column there. In order to do that, what I can do is we have pd dot concate function, and there we can pass our data frame DF students, and then we are concatenating this with passes. Okay, and we need to give this as a name because right now it is just concatenating it. If we do this, then it will not give get a name, so we need to rename this column name. So we can use dot rename, it's very important, and then we give a name called pass, and we want to do this concatenation in access equal to 1 because by default it is 0. And now if we see our data frame, so there it should have a new column pass. Okay, so now we know that we have a list of students and then their study hours, their grade, and whether they pass or fail. If you are coming from a SQL background, then it is very like you may have use a very important function called group by. The same thing we have here as well. So we can use group by, and then group by, and then you can provide the name of the column. So here let's see that out of pass and fail. So we can just see pass fail. This will give you a group by data frame. And now if you want to see a particular column, then let's see study hours. So we can see study hours, and then it will we need to provide certain function, either count, sum, mean, aggregate function, and so let's see the mean value in each case for mean value of study hour for each case of pass and fail, and that's what we get. If you want more column, then you can add more columns as well. For example, like you can even use grade here. And now we are getting the mean value for study hours as well as for the grade. If you want to do count, you can do the count function, that is also fine. It is giving the counts. So 15 plus 7 is 22, 15 plus 7 is 22. So okay, now another function, if you want, there are many functions. So another function which we can use here is, so we are utilizing all the functions, all the methods of data frame. So here like if you want to do sorting for some reason, sort values, and then you can do by, you can use shift and tab, and then you can see all the arguments. So here we have by, so we can use by. Yeah, and then we can provide the name of the column by which we want to sort. If we want to sort by study hours, then we can put that study hours, and by default it is ascending order. So if you want this, so you can put ascending equal to false, and now we get all the in descending order. Okay, so now let's see some visualization. We have seen some basic function that should be good enough for to continue this journey. Okay, so for matplotlib, for any visualization, the main important library is matplotlib. So we are going to use that one. Matplot inline, that is to ensure that the plots are displayed inline in this notebook. So that's why we have used this one. It is important to use this one, so always use this one. Then from matplotlib, we are importing the pyplot as PLT. So like numpy, np, pandas, pd, pyplot, we are using PLT as alias name. And now let's take a simple graph there. So in PLT, that's a library that has a function called bar or method called bar, and then we want to have a bar chart, and then what we can do is let's see quickly like what argument we have here. We can see here we have x, height, width, bottom, this. So let's give this x what you want to see in x-axis. So x-axis we want to have data frame dot let's say, what is data frame, or what is the name of data frame? df students, and we want to see the name of the student. Okay, for all the students it is missing one, so we need to provide one more argument, and that argument is height, because it's a bar chart, and height can be df uh, students dot let's see, grade. Okay, now this is the basic one, at least this much we need, and then we get this. Now if you want, you can make it look more beautiful. Here we are getting this bar container, this. If you want to remove this one, then you can use plt.show, and then you will see only the graph. Okay, now if you want to make this look very beautiful, then you can add more parameters here. For example, like here you can use color, and then you can see orange, and then it give you orange color. There are multiple colors which you can use, and then I'm going to use like plt.titles. If you want to add a title, then you can use plt.title. That will add a title here. If you want to, right now it is not giving you any x label or y label, then you can give x label and y label by using plt.x label and plt.y label. So that's what it is giving you, x label and y label. And now this is not coming to great here, so we can rotate this. So to rotate this, we can use this particular one, xtix rotation 90. And now it is rotated. And now if you want to add the grid line, so you can even use the grid line. So I'm saying that use the grid line. You can get these codes from internet, and then line style is this one, width this, and then we want this in y-axis, not in x-axis, and this is what we get. Okay, cool. Now the same thing we can do for different ones. So now this is created, you can just copy this one, and now suppose you want to see a different one. For example, like this time you're not looking for grade, you want to see this for study hours, and you can see that. Nice. uh, okay, and right now this is not coming good. If you want, what you can do is like you can sort your data frame. For example, like here BF students, and now I'm just sorting this here based on the study hours. So now this data frame is all sorted, and now if I run this one again, so this will become sorted one. So as you can see, the grades, and it's not a grade, it's basically study hours. So I can change this. So this is the study hours, and this is grades. I run this one as well, because it is not sorted by grades, it's sorted by study hours, so that's why it is different, but this is okay, fine. So you get the idea. So this is how we deal with this is how we create the basic graphs. Okay, moving on. Let's start doing some descriptive statistics. So for example, like for descriptive statistics, I have already said that DF students, we have data frame and then dot describe. That's the method which gives you descriptive statistics of all the numeric variables. But for some reason, if you want, okay, let me give you this one. What we can do is plt, that's for plotly, and plt dot hist, and we can pass this data. Say we want to see the histogram plot of grade, and then it will give you the nice histogram plot which looks like normally distributed. That's fine. Like what we see from here, we can also like create different variables and then put these values inside of variables. For example, like here we have the DF students grade, that's the variable, and now we can say variable dot min, variable dot max, variable dot mean. So this is basically a series, and in that series, this is series. Okay, so and that series we have these different function, and basically all these functions which we are getting from here, we can see that. Okay, now if you want a box plot can be very important, especially when we are looking for the outliers. So let me give you that. So we have a variable and then plt.figure fixed size. This is just to increase the size of the figures. Right now it is looking this much. If you want to make this bigger, then you can do this. You can even see that whether you want square or rectangular. So plt.boxplot is basically a function where we are passing this one. So this is basically the basic function here is this one, plt.boxplot, and then here we are passing this one, and then it will create a box plot. That's the box plot. And if you do the same thing here, that's what we are getting here. It just increase the size. With this one it increase the size. This is the same thing they are giving in this one, and then we just added a title and it is just showing you the picture. So that's how it looks. If you want, like what we can do, we can put all this inside a function so that we can just call the function anytime, to reuse the function. So that's a function here. So show distribution. So here we are loading this library, then we are calling these different variables. So we are just plotting whatever the variable data. If we will be passing any column here, with that column we will create the min, max, mean, median, mode, and then we have two plots here, and then we will be creating histogram plot, and then setting the y level as frequency, and then creating this. So that's basically the function here. And now if you call the function, so you can see this is the column from data frame dot column, and then that's what we are passing. So now grade we are passing, so the grade will go here, and grade dot min, grade dot max, not grade actually, it's df grade. So df dot grade dot min, max, mean, so everything is coming for the grade, and that's what we can see here. If I run this already, yes I did. So now if I run this, then it will create me nice the distribution plot as well as the box plot, which can be helpful here to see the mean and median, and also to see if there is any outliers and how is the distribution, whether it is left or right skewed. So those kind of things we can see here. Similarly, we have a density plot. If you are interested in a density plot, then we have this function here, show density, and the same way here we will be passing a column. That column will go here. This is just to control the figure size. Here we are just calling the variable data, that's the data frame dot column dot plot density. So basically if you want to see this, all it is doing is the same thing. We are just making this beautiful. It's not complicated at all. So dot plot and then dot density. So it is giving you a density plot. Okay, and now if we run the same thing here in this case, I just call that, I just like run that function, and then now I'm passing this column into this show density function, and it is giving the same thing, but it is just like giving like nice clean with title column, and then the mean and median showing in different colors. So that is basically what happening. So this is a reusable function which you can use for your analysis. This is a univariate analysis because it will take one variable at a time, and it will process that one variable and then create these graphs. Okay. So that's done. Then now let's see the different things. For example, like in any of the data frame, the few important things from a statistic point of view are range, which is basically maximum value minus minimum value, and then we have something called variance, and then we have something called a standard deviation. These are very important things. The range, like where the value is ranging from, like what is from where to where. Variance is like how much scattered is the data, and the standard deviation is just the square root of the variance. So what we can do is like we can create a function here. So what it is doing actually for column name in grade and study hour, so like it is going through this each column, and df student dot first it will go to the grade, and it is putting that as a column, then it is finding the maximum value for that and the minimum value for that. That becomes the range, and we have a variance function which will calculate the variance, and standard deviation is also, we have a function for standard deviation. So that's how it is calculating the mean, like all these things for all the numeric variables. So these are the numeric columns in our data frame. That's why we are looking into only these ones. And if you want to print, you can print this. So let's add this line print, which is basically printing range, variance, and standard deviation. So the for the grade, range is this, and for study hours this is this. So like this is a for loop, so it is running two times, one for grade, it goes through from here to here, and then it goes to the study hours, and then to do the same thing here. Okay. Okay, so now what you can do is like whenever we get our data, so we just do some basic statistics and some visualization to understand and explore data a little more, so that we understand the data in context much better. Now let's start doing some more deep analysis of the data. So what we can do here is like the first thing which we do is compare the data. So okay, let me copy this one here. What it is doing actually, df student, and we are saying that if the study hours is greater than 1, so let's see where the study hour is greater than 1. So in these cases the study hour is greater than 1. So this is basically like in some cases if we have outliers, like if we have a very less value or if we have very high value, then we can take that out. So that is what we are doing here. We are taking that value out where the study hour is less than 1, or we are only including those values where study hour is greater than 1. So this is the way we take care of outliers sometimes. So like like it has decided that okay, this is the outlier, and that's why it is giving this ones. For example, like let's give study hours in this case. Study hours, let me see if it is an outlier. There is outlier in study hours, so I'm just putting this study hours here. That's the beauty of function, you can just change one place and then I'm calling this function here, and then I see there is an outlier. That's why they have taken that one out, so that is the one value which is outside. So these are two whiskers. So we have q1, q2, q3, and then these are two whiskers, and any value which is outside these two whiskers is considered outlier in general. But it is not a like a rule, but like yeah, in general, like it is said that if the value is outside these two whiskers, then that is considered as outlier. So that's what we have done here. We have taken that value out, considering that that is an outlier. Okay, now let's compare the numerical values. So this is univariate analysis. Now we can do my bivariate analysis. So to do bivariate analysis, basically we will be comparing one value with the other value. So in this case, we are saying that okay, take name, and then on the y-axis take the grade and study hours, and that's what we get. So we are comparing study hours and grade for each and every student. So let's first see grade, and this is great. And if you want to include study hours as well, then we can just add this into the list. And now we are getting to this is a var. So df.plot, and then we can have this thing. Okay, now suppose like we have done all the analysis, we understood the data very well. So now let's come to the modeling part. And before doing the modeling, we need to take care of we need to pre-process our data. And for that, one of the most important thing is like we need to scale our data. Oh sorry, we need to normalize our data. So sometimes what happens, like as you can see that between grade and study hours is less and grade is high. So sometimes based on the value, it may think that the grade has more importance than study hours because the scale is different. To bring them into the same scale, we need to normalize our data. And to normalize our data, we have a library called min-max scaler. Again, there are like multiple ways to normalize. One of the standard way is to do that is min-max scaler. So that comes under this library sklearn in pre-processing. Min-max scaler. So here we created an object of min-max scaler, and now we are using df.sample. So these are the columns where we want to, yeah, just for the safe side, what we did actually, like we created a new data frame. So if so, for some reason if we mess up, or like if we are not happy with our this process, then we can go back again. So that's why we have just created a new data frame here. That's what we are doing here. Okay, and now normalize the numeric columns. So we have this one, and out of this only these two columns are numeric columns, so we put these two columns. And then what we are doing is scalar, which is our object here, dot fit. So fit and transform is basically like converting those values into the desired format and then applying it. That's what it is doing. So a scalar dot fit transform onto this column will basically normalize those values, and let's see that one first. And now if we see, we are doing the same plot which we did here, and this time it should be nearly same, so that we can see from here. Okay, now there's a relative difference, like, but not like a big difference. So like here, in this case, they are fine, they are same, but there are difference as well, because that's a relative difference between the study hours and grade. So now they have a scale into the same parameter, so that's good. Now if you want to find a correlation matrix, then we can do this, and it gives you the correlation between, because there is only two columns. So what we can do is like we can even pass that particular column, so between two columns. So one is let's see, the column is grade, and between grade and let's see here we can put study hours, and the correlation between them is 0.91. So they are positively correlated. So more than anything, this is the direction that okay, they are positively related. And generally this value lies between -1 to 1, and that indicates the strength of the relationship, how strong is the bond between a grade and the study hours. So more the study hours, more the grade, or if the grade is high, then the study hours are also likely to go high. So that's basically what it says. So if you want to see these things in action, what you can do is you can uh, so this is what we have seen from the normalized one. But if you want to see this from the data set, we can do that. Okay, now let's just take this one. And then, so that's our data frame, and that data frame we have already seen the relationship between these two, and that is positive. So if we plot a scatter plot dot scattered, and now I do this between x and y, so that x is in our case is say study hours, and y is in our case grade. Okay, let's see. And then we can see they are like positively related. As we go on study hours, the grades is also increasing. That looks nice. Yeah. So now further, if you want, we can also add a regression line here. So for that, let me copy this thing here. So I'm using this library called states. So from SciPy import states, so that I can use all the one. And now I'm again, like, it's always good to create a new copy of the data frame. So I'm creating a copy of a data frame into DF regression, just like these two columns. And now after that, like, I want to get the regression slope and intercept. To do that, yeah, so we are using this state dot linear regression. So yeah, we are putting this linear regression, and then we are saying, okay, let me run this one. So it says that we put the regression equation between study hours and grade, and then we see that the slope is this one and the intercept is this one. So the equation is like y equal to mx plus c, if you remember in your school, and the intercept, the c is minus 17. So if the value of this is 0, then that intercept will become the 17, so like that. Okay, so that's basically it. And if you want to see this in display, then we can do the same thing into graph. So m regression, that's the study hours, so that's become our x. So we are basically checking the value of y, which is grade, based on the study hours. Okay, now we already know the value of intercept, we already know the value of m, which is that slope, and then we are just like trying to create the line, calculate the error between this and this. So the error is always between the y minus y hat, which is a real value versus minus the predicted value. Let me draw this line. So basically what happened, like, out of this scatter plot, they try to come up with a line which is best suited for all these points. When I say best suited, that means the distance of all these points from this line should be minimum. So if so basically the error which they generally check is the y predicted minus y observed. So, and then they look for this one. There are different metrics for error, like mean absolute error, MSE, root mean square error. So there are multiple things to do that. But yeah, basically this is what we get. And now if you want to check the errors, so which we also call residual, so that you can do, for example, like here. So here, this is the grade. This is what we are getting from this function, and then this is just a difference between this and this. As you can see, this minus this is minus 13, 9, minus 2, minus 3. So this is basically error, or we also call it residual. Okay, so that's pretty much, this is it for this particular section. I think it's already very long class. I will try to put this into 2 classes from now on, but I hope it helps you in some way. If there is any question, please let me know. I will be happy to reply. Thank you so much.